Okay, good afternoon, everybody. Welcome to this session on making BIM work harder for you, technology that helps you reuse, reduce, and remove. Before we get into it, just a little bit about A2K. If you've not been to any of our sessions or don't know anything about us, we are a global design technology company. We are primarily owned by a large company called RIB. We have offices all the way around Australia and New Zealand, and now with other companies in other parts of the world. We focus on providing design technology products, services, such as implementation, training, and so forth. If you need any assistance with any of those items, feel free to reach out to us. There'll be details on the last slide. Okay, look, we're just going to dive straight into this, and by now you probably should all know why you need to use a BIM. But what you may not necessarily all know is how the BIM can be used across many of these different life cycle stages that you can see on the screen at the moment. So in this presentation, we're just going to take a very, and I do mean very high level overview of these products that you can see on the screen at the moment, and where they can fit into the different stages of the project's life cycle. I guess the important thing to remember throughout the presentation is, just as you've changed from 2D to 3D, or maybe you haven't yet and you're currently looking at making that change, so too are you having to evolve the way that you use the 3D. And in this case, we are talking predominantly about a BIM, a building information model. And we need to become less reliant on 2D workflows and paper-based workflows as well for our methods of delivery. Because these kinds of delivery methods become outdated rather quickly. And so we need to put a greater focus on moving towards a more purely digital workflow, and preferably one that revolves around using the 3D. So we're going to obviously start right back at the beginning, and we're going to move our way through to the end of this process. And in this case, we're going to start with the sketch design. Now, even at those really early conceptual stages, there is actually value to be gained from working with a BIM. So in this case here, using Revit's massing feature, it gives the users the ability to create complex forms, if need be. They could be quite basic still. To create these complex forms. And then using these forms by way of the data for outputting to maybe other systems, or maybe using internally inside of Revit so that we can further do things like analysis. So in this example here, we can see that we've got a building mass that's been divided up into its floors, and those floors are then giving us floor areas so that we can start working out some feasibility level information. And here's a slightly different take on that massing process inside of Revit, where we can see some additional data has been added into the project. And in this case, it is more to do with the function or the functional use of the spaces within the building, whereby we can start then classifying things like bedrooms. So this could be a high-rise residential apartment. So we could be classifying things like bedrooms, maybe a retail space at the bottom, car parking, and so on. And it's the addition of this extra information within our BIM that we can then utilize through a better feasibility process, rather than just doing some drawings and then having to work this information out by hand. And alongside your typical data that you can get out of those feasibility models, such as the areas and the functions as we saw in those previous examples, we can also start calculating things like the building performance. So here we can see some examples whereby we've got some solar radiation analysis occurring around the envelope of the building, which can be useful for working out obviously which facade sides are getting the most impact from the sun, so that you can address that through facade fixtures and so forth. Or it could be optimizing the positioning of things like solar panels to obviously optimize their power generation. Or it could also be things like lighting analysis. So using, once again, the same sun information to be able to work out how the natural daylight is flowing through the building, or if it's not, then working out the artificial lighting within the building as well. And this can be done either in a 2D fashion or possibly even by way of a 3D model. So we're starting to use the information within the model for things like a real-time analysis and or a walkthrough. So a 2D drawing, such as what we saw in the previous slide, only tells us part of the story. Whereas when we dive into a BIM like this, we start seeing more information, particularly things that may be overhead that are critical to our analysis review. And because these, in some cases, are real time, it means that we can always go back to our design model, make changes that we think are going to affect the performance of the building, and then within seconds, come back to our visualization to see how it's been affected. And this idea of analyzing the BIM is moving forward through the addition of generative and iterative design practices. Here we can enter in some design criteria. It might be things like optimal position for capturing solar radiation, like from the previous slides. It could be optimal position for wind flows, noise reduction, and so forth. And when we put that criteria into these generative products, we can then get an output of many different options that may suit your design criteria. It's kind of like an automated version of Revit's own design options feature, but on steroids. It provides insights into things that you may never have thought of, and these options that it returns can then be further iterated until you come up with maybe 1 or 2 design results that you're happy to move forward with. And it's not just for the building envelope design. It is for most aspects of the design process. Room layouts, furniture layouts, lighting, maybe acoustical, ingress and egress from the building, and so on. All these factors come together to produce an optimal design and will no doubt eventually extend into structural and services engineering design and analysis in the future. So now moving away from our concept and sketch design, we start moving into this design development stage. So as the building develops, more design analysis may be required. Now as the building starts taking further definition, we may be required to, meet detailed building code requirements. In this case here, in this example, you can see, this is using newer and known quantities, like things like door locations, furniture, and maybe even the heights of elements as well. And in this example here, we can see an occupant flow analyzer that has generated a graphical and easy to read diagram with the hope that this is now meeting those code requirements. It gives us a different and hopefully a better way to review it rather than trying to work it out with pen and paper. And as we maybe move closer towards the end of the design development stage, additional data is likely to be entered into the BIM. Probably most notably for things like structure and services engineering. And so tools like BIMlink can help us to review, export, and may even import the data between Revit and those other systems that you may be using. This could be for resizing structural members based on new calc loads, or possibly updating MEP systems with serial numbers in readiness for fabrication, and so on. If the data is stored inside the BIM, then we can work with it either within the BIM or in an external application and move it between the two systems. So now moving into the estimating and tendering stage, this in particular, the estimating, is an often missed opportunity in the overall workflow. From an A2K perspective, many companies are still performing this with 2D tools. Quite often we still see people entering in information manually, or even still doing it on pen and paper. Yet this is one of those stages that can reap the most value from utilizing a BIM. We break it down into two steps. Firstly, through quantification, and then through estimation. Legacy products like Navisworks can give you a detailed quantities report so long as it's been modeled and then it becomes quantifiable. But even for items which are not yet modeled in the design, because maybe it might be a little bit too early, they can still be captured through other digital yet 2D takeoff methods. Typically, systems like this have the ability to do 2D and 3D takeoff, with a preference obviously towards a 3D takeoff. And products like Assemble not only take a similar approach, but also tie in other features like design changes and integrating the estimation process closer. This provides a more efficient workflow that is not only more accurate, but it's also faster. And in particular, when linked to other cloud systems, it also produces more immediate results. Moving further again, and this time into the detailed design stage, this is when we might start working with other disciplines, so across companies, and things like BIM 360 Docs allows us to take our BIMs and maybe drawings that it generates and putting it into a cloud system for all to access. Not only do we put it into these systems for sharing, but it exposes the data stored within those files that we're uploading so that they can then be used in other various ways, maybe for data extraction, maybe for finding out element properties, and also contributing information back into the process through things like markups and issues. The BIM in this case becomes an integral part of the design review workflow rather than relying on hard copy drawings or even soft copies of those files. And probably most importantly is the ability to then understand how designs are changing as time goes on. Regardless of whether it's 2D or 3D, these, in particular, cloud-based systems are able to make design comparisons between versions of those files so that you can better understand what's changed and how it affects or impacts upon the work that you're then required to do. And of course, making them accessible by a mobile device is critical so that that same BIM and drawing information is able to get out to those out on site. And we'll touch on that a little bit later on. Coming back and focusing more on the design aspect of it though, and as the design teams are busy generating and sharing BIMs and drawings, further data is also being generated. In this case here, we're looking at fittings, fixtures, and finishes. Using Durofus's add-in for Revit, the model and the Durofus database actually work together as almost a single unit, ensuring a cohesive sharing of design data between the modelers and those specifiers. Any model design changes are synced back into Durofus, so that's a Revit to Durofus workflow. And probably more interesting is the reverse workflow in this case, whereby missing design elements in the Revit BIM are flagged by Durofus and which are then used, or that knowledge is then used to auto-populate the model with those missing elements. I said before that they work almost as one and they have this nice bi-directional syncing capability. This is not just a syncing process, but an intelligent syncing process of BIM data. And this is with all with the grand expectation of exporting the data through reports such as room data sheets. This process ensures that the reports match exactly what is represented in the BIM. And in a similar kind of vein, A2K's RevTag Revit add-in provides model modifications and annotation, but in this case for MEP system elements. What is otherwise a fairly slow and tedious process, the split feature contained within this tool firstly splits long duct lengths into manufacturer-specific lengths and then tags them accordingly. The tool adds more detail and accuracy into the model prior to the fabrication process. So now we're getting closer to that fabrication and construction stage. Moving through the pre-construction stage, this is a space where you probably already appreciate how much the model coordination process plays into the design and pre-construction stages. But even that is evolving. The days of manual clash detection are fading in favor of more automated systems. Here we see a matrix of clashes within the project that has been generated without requiring any human input, other than making sure that the files are available to the system in the first place. And then we start drilling down into a single result found on that matrix so that we can then start focusing on the individual issues, which are then assigned to particular staff from particular companies, ultimately for a resolution. Now, this probably has a little bit less to do with how we make BIM work harder at this stage, but this is very much a space to watch in the future. As advances in machine learning and AI continue to evolve, so too are the system's ability to interpret the BIM's element data, to make decisions on the next course of action, such as what to do with this particular clash. The system already knows what disciplines these two items belong to, who is working on the project, and the company and discipline they belong to. And it also knows the severity of the issue by how much it's overlapping. And there could be other design criteria that it can interpret or gain from this clash. So therefore, it's actually not a large leap for the machine learning to then assess the data. So this is where we start tying it back into the BIM. It's not a large step for the machine learning to then assess the data for an automatic assignment of responsibility for this clash. And that idea of using machine learning or AI algorithms based on BIM data is becoming more prevalent. But of course, if you still want to do it the old school way, then products like Navisworks are still available. And speaking of Navisworks, additional data can be augmented with the model. This data may be derived from other databases, which in this case here, it could be data that represents an element's progress status, such as maybe whether it's been fabricated, delivered, installed, and so forth. It might be augmented with operations data, so attaching things like warranty information, serial numbers, barcodes, installation dates, and so forth. Using the BIM and secondary data is actually a great way or a great method for visualization. The fabrication stage has always generally been a technology laggard, but with recent mindset changes and looking towards the manufacturing industry for inspiration, this stage of project delivery is now making some rapid advancements. Revit add-ins like Strucsoft's metal and wood framer are by no means new, yet using the data that it produces is. And this is where the advancements are currently being made. By firstly generating a fabrication level model, complete with element data, this can then be exported or directly connected to the fabrication equipment. Here we see Howick's light gauge metal fabricator, which cuts, punches, folds, and even serializes the parts ready for assembly. This has the ability to be prefabricated in a factory or made on demand out on the site. Using the BIM and drawings via a cloud platform like Autodesk's BIM 360, the trades then know exactly how to erect the structure. And this is also somewhat similar in the mechanical services industry. Industry bodies like the AMCA and their BIM Oz product are leading the drive to create fabrication level parts in an effort to minimize BIM waste. This ensures that the output is accurate and coordinated, meaning that it's constructible, and also reducing BIM data entry. What goes into the model at the beginning is never deleted or redrawn at later stages. Instead, it grows throughout the different project LODs up until the point that it's installed. So now we start moving out into the field during the construction stage. And much like fabrication, construction is always going through, is currently going through many changes, with some spaces more rapidly than others, and is one of those few stages of the project that has the most to gain. And oh boy, will there be some changes coming over the next 10 years. But today, none more so than moving site-based staff from paper and into the digital world. Data entry and re-entry is one of the most inefficient tasks on the job site. It fails to leverage data contained within other systems and the BIM or drawings. And it fails to put data, the data that it's capturing, back into those systems and the BIM. Take these two following examples. Using mobile-based apps, site-based data is entered in once and is immediately available to other users. This is data which is either as supporting information to the BIM or directly entered into the BIM. It just depends on the requirements. And in reverse, with the design team putting the BIM and other drawings in a cloud-accessible platform for the site staff to access, means the design team can readily get the BIM, drawings, and other supporting information to the site staff without delay. More and more, site staff are relying on the BIM over the use of drawings. And this is especially true for surveyors. When downloading the BIM into their equipment, they now have accurate model data for setting out on site. This completely removes the drawings which are susceptible to mistakes through human error. And once the structure is built, the reverse process occurs, with the as-built captured back into the equipment and subsequently compared to the design model to find deviations. And finally, moving on to the operations stage. In our developed world, I guess it's fair to say that there is an order of magnitude more paper drawings than there are digital, with the challenge to now transition this into digital for new projects, and possibly, over time, convert the paper drawings for existing buildings into digital. By moving our project data throughout all stages of the project, it is with the intention of delivering a true and complete handover. And this is actually reflected through the delivery of an asset information model as per the new ISO 19650 standards documents. And it's also important to note the role which the cloud is playing with these technologies, current and in the future. As a delivery mechanism that stores data and connects systems, it is possible the greatest resource available for making the BIM work harder is through cloud systems. This does not mean that you have to become a developer. Rather, you can look for systems that work together to solve your workflow problems. By interconnecting BIM data or creating custom interfaces, new solutions and insights may be uncovered, such as this web example that is showing us a BIM with its corresponding floor plan and some other charted information. And lastly, think before you print. Take a moment to think about how you can trim down the steps in your workflow. You need your BIM to work harder, not you. That is not to say that you don't need a 2D output, but rather think if there is a smarter 2D workflow, or better yet, a workflow that purely revolves around the BIM and its connection to other BIM systems. Because at no time throughout this presentation was printing to a file mentioned. Thank you.